Hi everyone, how you doing? Welcome to the part 3 of my RakNet and Leadwerks tutorial. In this lesson we are going to learn how to spawn a player inside inside our framework. If you remember last lesson in part 2 we made a client and server and we got them to connect to each other. This time we're going to make it so that after you press a button a player will be spawned. So let's start off with our server. So we'll go back, just open whatever you finished in part 2. If you haven't done part 2, I suggest you have a look at part 2. And let's just open some of these. We'll open our main file, we'll open our server. Yada yada yada, just a sec. Alright, so we'll start with our server. Okay, we'll ignore that for now. The first thing we have to do is we have to make a player class. Now, it's very simple to make a player class. You pretty much make it exactly the same as you would for a single player game, except with one or two minor differences. So here's my player class. Let's go through player.h here. So I've included RakNet includes an engine, of course. And here's my class description. Now you'll notice this is a bit different. You wouldn't do this with a normal character class. We are inheriting from another class that is within the RakNet API, and that is, so the player class is inheriting RakNet network ID object. Now I might have explained this earlier, but every item that you want in your game that you want to network has to have an ID that is consistent between the server and all the clients, so that everyone knows what everyone's doing. Otherwise you'll get things messed up. If you get a packet and you don't know what object to put it to, you're screwed. So you need IDs for each of them, so you can say, okay, this packet says move forward for that object. So this is what this is for. Very important that you inherit that from the RakNet API. Okay, so it's a very simple player class. All we've got is here in private, we've got a mesh and a body. We've got a constructor which takes two vec3s, which will be the initial spawn position and spawn rotation, and the actual function to spawn a player with the spawn position and rotation. So let's go to the description, our functions for the for player.h, player.cpp, and here's our constructor. All our constructor does at this point is it calls the spawn player function, putting whatever the user chucked in here into the spawn player, and all it does here is the body, it creates a body box, the mesh creates a cube, it parents them together, positions them at the spawn position as it was given, rotates it at the spawn rotation as it was given here, sets up the collisions, sets the body mass. So very simple, nothing new here, you should all know everything about that. The key thing to take away from here is this. Got to inherit from network ID objects. Okay, so we've done that. Now we're going to go to our server. Now I've just got to check the times here. Alright, because last 4 times I did this video, I went too long and it crashed, so there might be a few stops. Okay, so let's go to our server.cpp and server.h. There's a few extra things you're going to have to add in now from last time. Obviously you're going to have to include your player.h, that's a given. And there's some others. You're going to have to add a couple of things. Okay, here we go. We have to add a pointer array to our what is it? To our player class, because we want to create an array of players. We don't just want to create one player. That'd be kind of pointless. And that's a pointer. Okay, so that's important. We've got an integer called control player, an integer called numplayers, and a bool called spawned. The spawn bool is basically so that if the player spawned and somehow spawn player is called again, it cannot spawn, because if spawned equals false. Numplayers is not the maximum number of players. We've already defined that here, max players. But numplayers is the amount of players in the game currently. So it starts at 0. So 0, starts at 0. Now control players, I'll explain this a bit more later, but basically control players is used so that the player on the server or the player on the client can only control the player that they spawn, and we'll see how that works a bit later. Okay, up here we've got a bit more. We've got that we've added new. We've got the spawn player. The server also has to have the spawn player function, which will do a whole bunch of other things, as well as calling this, as well as creating the player and spawning it. Go up here. We have RakNet message ID, type ID. Now I explained in the last tutorials that when you send a packet over a network, it has to have a message ID at the beginning. And the message ID is read, and then from there you can figure out what you want to do with the packet. So if the type ID is, if the message ID is that's sent over the network is spawn the player, then you can react to that by saying spawn play. If the message ID is move forward, you can react to that by moving forward. So this is just so you know what to do with the packet. We'll go into that a bit more later. We need a player network ID variable, which is a RakNet network ID. That's, as I explained before, the object IDs. And we need the network ID manager variable to store that. And that's just to manage all the network IDs. So in short, we're including those and those extra. Let me just quickly scan. Oh, and this as well, of course. That looks like it. Okay, so we've done our server.h. Now we just want to go into here into server.cpp where all the action's happening, and we're going to get started. So what we'll start off with first is our spawn player. Let me just check the time. Should be good for another few minutes. Okay, so as I said before, there was a bool called spawned, right? This bool starts out as false. You'll see when we create the instance, we set spawn to false, we set num players to 0. So these two get defined straight away. Num players 0, spawn to false. Okay, so if spawn equals false, then you can do it. And then at the end, you'll notice that spawn equals true, so it won't do it again. Okay, that's that out of the way. First thing we do when we spawn the players, we want to make an instance of the player class, this player class over here. Right, and we do that in the array of players, whichever is num players. So if you're the first player to spawn, your player class will be player and then 0 in here. If you're the second player to spawn, it'll be 1. If it's the third player to spawn, it'll be 2. Num players just increments. You'll see down here, num players increments every time a player is spawned. So yeah, basically that's that. And we've chucked in our position as 0, 0, 0, and rotation as 0, 0, 0 for that. This shouldn't be new to you. It's not anything to do with networking, it's just coding. So here we're going to define our type ID, which I explained earlier. And the type ID, because we want, when the server receives it, we want it to spawn a player when we send this message. So at this point, the player has been spawned on the user's PC only. It hasn't sent anything out to get it spawned on any of the on the server or any of the clients. So this is the next step. We send out the information about the spawn. So we set the type ID to spawn player, and where we get that type ID from is here. You'll remember we made custom network enums.h, where we define our custom network enums. Duh. So basically, to do this, any custom ID you want to make, you just make it equal. So ID spawn player, I made that up, equals ID user packet enum plus 1. ID user packet enum is defined in RakNet, and you just plus increment it for each new type that you want. You can make as many as you want. Okay, so back to the main thing. So yeah, we set the type ID. Now we have to set the network ID manager. All right, so we want to set. Okay, so we set the network ID manager for player. This set network ID manager comes from our inheritance here. Okay, so that's why you need that. We're setting the network ID manager of the player that just spawned to @network ID manager, which is what we wrote here. We're storing it in that variable. Okay. Then what we want to do is we have to get the network ID. So player network ID, which we find here, equals player numplayers, and then get network ID. Because the player has the inheritance, it can get the ID from here. But coming back to this inheritance here again. Okay, the next thing is just a quick assert to check that it worked. I'm not going to go through that. Doesn't really matter, but it's good practice to have the assert there just in case it didn't work. It's basically just checking if when you get the network ID from that player that it equals the network ID that you got. Otherwise, something's screwed up. I'm just going to stop it here and restart in a second so that I don't lose this video. Alright, that's saved well enough. So let's continue. Okay, so the next thing we're going to do is we write bit streams. You want to know what bit streams are? Well, doesn't really matter. The thing is that there's two main ways to send things over network. You can send a packet that contains a structure, or you can send a bit stream. Probably other ways as well. You can send a straight text, you can send a string, you can send just a single variable if you want. But I recommend bit streams. It just makes things easier, and why not do things easier? So first we've got to make a bit stream, and so RakNet bit stream, and we're going to call it BS out because it's an outgoing bit stream. Duh. Okay, so the way we do this is we go BS out.write. Now the first thing you always write in a bit stream is your type ID spawn player. That's the first thing, because when the server or the clients get it, they're going to read the first bit of information in the packet, in the bit stream, and try and figure out what the type ID is from that. So it has to always be at the beginning, type ID. Next thing we're going to write is our bsout.write 0. Now why I've done 0? Well, that 0 corresponds to this 0. You could make it a variable. I'm just being lazy and making it, hard coding it myself. So you can see what I've done here. I've written position X, position Y, position Z. Then I've written rotation X, rotation Y, rotation Z. And it's very important to write these things in order and read them, because later we're going to read them. We have to read everything in the same order. So we write position X, Y, Z. We write rotation X, Y, Z. Then when we read it, we have to read in the same order. So we have to read the type ID first. We'll read the position X, Y, Z, and then read the rotation X, Y, Z. We'll get into this in a second. But so just so you know, we're writing position X, Y, Z, and rotation X, Y, Z. The last thing we want to write, so that's all the information we need to send to spawn, really. I mean, if you're doing something else, you'll send more information, you'll send different information, whatever. But this is a spawning bit stream. So we go BS out, write, and we want to write the network ID of this player that we just spawned. The way we do that is we go bsout.write, and then in the brackets we go player numplayers, which is the player that just got spawned, and get network ID. That obviously comes from here, the inheritance, once again. Now, our bitstream is written. This is all written into BSOut now. And we're ready to send it. So, here we go. We go set server, because that's what we made before, if you remember. A server somewhere. Set server equals RakNet peer interface. Okay. Server send, then we're sending BS out. We've got to have and BS out. We're giving it a high priority. You can change this, doesn't have to be high priority, it can be low priority. Just go to RakNet.com and you can find out all the other options. We're sending it reliably and ordered, so it won't read the packet until it's all there and in order. If you don't do this, packets can, sometimes arrive at different times and out of order, and it just reads. So this will make it reliable and order. This is an arbitrary 0. It's just always 0. There might be something to it. I don't think there is. But yeah, anyway. And then this RakNet unassigned system address. Now, this means yourself, basically. Unassigned system address is yourself, because you assign a system address to all the other clients or server, whatever, but yourself you don't need to, because you are yourself, duh. And now you're saying, this true, okay, gets a bit tricky. This saying is it's true that you're sending it to everyone except